here we go with our Unit 8, Lesson 8 notes, and we are going to talk about solving radical equations. So remember, radical means anything with some sort of root. So like square root, cube root, any sort of root, the nth root, that's what radical means in terms of a math term. So if you look at this whole page of notes, every single one of our equations has some sort of radical, whether it's a square root or a cube root. And we're going to talk about how to solve an equation, solve for x, when there is something like this in the equation. So the first step in doing this is to isolate the radical. Isolate means get it by itself. That means we need to remove everything that's on the outside of the radical and move it to the other side. So that means we are going to add or subtract, then multiply or divide. So for example, if you look at example 1, I have square root of x minus 6 equals 0. Well, this minus 6 is not in the square root. I want to move that to the other side, so I'm going to add 6 to both sides, and that leaves me with square root of x equals 6. And now my square root is isolated. It's by itself on the left side of the equal sign. Step 2 is to undo the root. So the opposite of square rooting something is to square something. So we're going to square both sides. And guess what the opposite of taking the cube root of something is? You guessed it. We're going to cube both sides. Okay, so to undo the square root in example 1, I'm going to square both sides. If I square the square root of something, those undo each other, so we're just left with x, and 6 squared is 36. All right, let's try example 2. Step 1 is to isolate the radical. And in this case, it is isolated. Even though we have this plus 1, that plus 1 is inside the cube root. So I'm not going to subtract 1 quite yet. So step 1 is already done. Now I'm going to undo the root, which means I'm going to cube both sides since it's a cube root. And if I cube the cube root of something, I am just left with that something. So I'm just left with x plus 1. 4 cubed is 64. And in this case now, I have to finish it up and solve for x. So I'm going to subtract 1 from both sides, and we get x equals 63. All right, example 3. First step is to isolate the radical. So this 2 is not in the square root, so I'm going to get rid of it, which means I'm going to divide both sides by 2. That 1's out, right? 2 divided by 2 is 1. I'm left with the square root of x plus 2 equals 2. Now I can undo the square root. The square root of something squared is just that thing. 2 squared is 4. Finish solving for x. We get x equals 2. All right, I would like you to try these first 2 problems that say you try. So pause the video, do these 2 problems on your own, and then check back to see how you did. All right, so for the first one, you should have gotten x equals 28. And for the second one, you should have gotten x equals 23. If you did not get those answers, go ahead and pause the video again, compare your work to my work, and try to figure out where you went wrong. I want to do this one together because at first glance, it doesn't look like we have a radical. However, what you have to remember is that anything to the 1/2 power is the same as the square root of that thing. And also, which we're going to see in another example, is that if I raise something to the 1/3 power, that's the same thing as doing the cube root of that thing. So really, I could rewrite this equation as the square root of 4x equals 6. And those are exactly the same. They are equivalent to each other. And after I do that, it's really just the same thing that we've been doing so far. To undo the square root, I'm going to square both sides. That gives me 4x equals 36. I'm going to divide by 4. We get x equals 9. So same kind of idea here with example 4. I have x plus 1 to the 1/3 equals 3. That is the same thing as the cube root of x plus 1. Since it's the cube root, to undo it, I'm going to cube both sides. This just leaves me with x plus 1. 3 cubed is 3 times 3 times 3, which is 27. Subtract 1 from both sides, we get x equals 26. All right, example 5. We have a couple things outside of the square root, so we need to isolate the radical first. First, I'm going to add 7 to both sides, which leaves me with 3 times the square root of x plus 2 equals 12. Then I'm going to divide by 3. Now I can undo the square root. Gives me x plus 2 equals 16. If I subtract 2 from both sides, x would equal 14. All right, one more together here. Same idea. We have this 8 and we have this minus 5. So I need to get the cube root by itself to start. So I'm going to add 5 to both sides. Then I need to get rid of this 8. So I'm going to divide. I don't need to do anything with the 3 or the 4 because that is inside the radical. Now my step is to undo the cube root. So I'm going to cube both sides, which leaves me with 3x minus 4. 2 cubed is 2 times 2 times 2, which is 8. And now this is just a regular equation, a linear equation. Add 4. I'm running out of room here. 3x equals 12. Divide by 3, we get x equals 4. All right, last thing is for you to try these 3 problems on your own. So please pause the video, give these 3 a try, and then when you're done, restart the video and see how it went for you. All right, for the first one, you should have gotten x equals 0. This one is kind of a little funky because of the negative and that sort of thing. The second one, you should have gotten x equals -6. And then this last one, I kind of wanted to finish going through together because it works out kind of funky here. So we end up with, when you get the radical by itself, you end up with 8 over 5. It doesn't divide evenly. But that doesn't mean we can't solve the equation. I'm still going to go ahead and square both sides. So that gives me 2x minus 1. 8 squared is 64. 5 squared is 25. And now I'm going to add 1 to both sides. And when I add 1, basically I have to get a common denominator. So what am I doing? I'm doing 64 over 25 plus 1, which 1, if I want a common denominator, would be this, right? 25 over 25 is 1. Now I can go ahead and add these together, which gives me 89 over 25. Okay, so I have 2x equals 89 over 25. Now I have to do 89 over 25 divided by 2, right? I need to divide both sides by 2 to solve for x. Dividing by a number is the same thing as multiplying by its reciprocal. So that gives me 89 over 50. So x equals 89 over 50. That one was definitely a little tricky with all the fraction work in there. But if you were doing okay with all the rest of them, you should be totally golden. Next time you're in class, we will do a lot of practice with this and make sure you're feeling good about solving radical equations. We'll see you then.